So I'm going to be doing number 31 from chapter 6. And after reading the question, we basically learned that a little ball is moving through some shampoo. And we know that the resistive force is going to be equal to its weight because it is at terminal velocity. And they tell us the terminal velocity and the weight of the ball. And we can set y positive as the direction it's moving in because that'll just be easier for us to work with. So for part A, we're trying to solve for the value of constant b, and the resistive force equals b times the velocity. And b is just kind of like a constant of the medium it's working in and its shape. So we want to do the sum of all forces equals mg minus r, and that's also equal to ma because it's just a force. So we can say ma equals mg minus bv because r equals bv, like I said before. And acceleration is the same thing as dv over dt, so we can plug that in also. And we can move it around to get to isolate dv over dt on one side, and I'm putting a little star next to that because we're going to go back to it later for part B. So we want to set the acceleration to equal to 0 because at terminal velocity it's just going one velocity and it's not accelerating. So we can do that. And 0, well, we can just move it around to get that equation. And then b equals mg over vt, and because we're setting it all equal to 0, it's at terminal velocity. That's why we added the little t next to the v. And we can then just plug in our known variables, which is mass times gravity divided by terminal velocity, to get b equals 1.47 newtons times seconds over meters. So that is part A. Okay, for part B, we're trying to solve for the time t when the bead reaches 0.632 of its terminal velocity. So back to that equation that I said before, dv over dt equals g minus bv over m. Now we want to move that around in terms of v to get v equals mg over b times that. And that equation is just solving that expression in terms of v, and you can see how that's done on page 149 of our book. It's kind of the same thing we did on this page that we're going to go over later on in the year, so you don't really have to worry about it now. And I already asked Mr. Greenberg that, so don't worry about it. Okay, so then we can plug the terminal velocity as mg over b because of our equation that we used earlier, that 0 equals mg minus b times terminal velocity, to get v equals vt times that 1 minus e to the negative bt over n power. And we know that the velocity is 0.632 vt because that's what they told us at the top. That's when we're trying to find the time. So divide velocity on the terminal velocity from both sides, and you get this. And then if you subtract 1 and then divide by negative 1 on both sides, you will get 0.368 equals e to the power. And so we're going to take ln on both sides, and negative bt to the m, that exponent, we can move that in front of the coefficient because it's ln. And then ln to the e, we can just set that equal to 1. So we can move our equation around to solve for t. T equals negative m over b times ln of 0.368. And then we can just plug in our known variables, which is at the mass, and then also our constant b. And when we solve for it, we get time equals 2.04 times 10 to the negative third seconds. That was part B. And then part C is the easiest. Okay, so in part C, we're trying to find the value of the resistive force when the bead reaches its terminal speed. So R is equal to mg from our picture. We can see that. So R equals mass times gravity. And we know our mass and we know our gravity, so we just plug that in to get R equals 2.94 times 10 to the negative second newtons. And that was problem 31 on chapter 6.